talk about describing categorical data. We've done a lot of describing of numerical data, which has a lot of calculations and a lot of interesting things you can do with it. Describing categorical data, though, has some limitations of what you can do, and it helps us think about probability. So we waited until now to do the describing categorical data just because it starts feeding into probability nicely, and it makes it a little bit more interesting to deal with it in that context. So just like with numerical data, we have univariate categorical data and we have bivariate categorical data, and we can deal with both of those in a couple different ways. So when we're dealing with univariate categorical data, we have either relative frequency tables or discrete probability tables. That is the way that we can utilize this to branch into probability. We'll look at frequency tables as well, and then show how those are related to these. Percents and probabilities are roughly the same thing. It just depends on how you're applying these ideas, and by that I mean like in what time frame. So percents are current or past tense things. We'll look at the data from our class and look at what percent of students are considered themselves procrastinators. So like 10.3% of students consider themselves procrastinators, and we could say, oh yeah, that's true for spring term, okay? And just say that's what was true in spring term for this data. If we are then thinking about those percents in the future, those are probabilities. And those probabilities are the same thing as percents. I'm still going to say 10.3% of students consider themselves procrastinators, but I'm not going to apply that to the future. So there's 3 teachers teaching the sections that answered the survey, me, Kelly, Scott, and Michael. And we might say, okay, well, that data probably or possibly represents all stats students, and we expect those percents to stay roughly the same. So in the future, we'd expect 10% of our students to not consider themselves procrastinators. So it's just a matter of what time frame you're thinking about percents as to whether or not you're considering them a percent or relative frequency, or you're considering them a probability. So if we think about that question, do you consider yourself a procrastinator? This here is a frequency distribution. It's just the number of times something happened. So 9 people said no, 52 people said sometimes, and 26 people said yes. This is about the limitation of what you can do with categorical data, univariate categorical data. You can show it in a pie chart or a bar graph. And yeah, I mean, it's interesting to summarize the data, but this is just a summary of the data, the frequency distribution. If we think about relative frequency instead, this is now putting those frequencies as percents. It's another way of dealing with the categorical data. It's basically telling you the same thing. It's just putting it in a different perspective. So 10.3% of students said no, that they didn't consider themselves a procrastinator. And I find that just by taking my 9 people that said no and dividing by my 87 people total. So same thing with sometimes. This 59.8% came from those 52 people that said sometimes divided by the 87 total. Okay. And then the same thing with the people that said yes. 29.9% was the 26 people out of the total. So this would be then us saying, well, these are the percent of students in our classes that consider themselves a procrastinator. If I project this onto the future, I'm now considering this probabilities, and I would call this a discrete probability distribution. They mean roughly the same thing. It's just, again, a matter of time frame. When am I applying these percentages? One thing to keep in mind with probabilities is that not everything projects into the future appropriately. So if for whatever reason we think spring term students are different than the students we're going to have in summer term or fall term, we wouldn't want to say, oh yes, this is the probability all the time of students considering themselves procrastinators. So now what about bivariate categorical data? This table that I have here is called a two-way table. It's also called a contingency table. So those two phrases mean the same thing, two-way table and contingency table. They're synonyms of each other. And this is one way to show bivariate categorical data. So I've got two different variables. Do you consider yourself a procrastinator? And do you have a grant or scholarship? Those are my variables. And then this shows me the different ways people answered in relationship to those two variables. So if I'm looking at do you consider yourself a procrastinator, that's the one we were just dealing with, I can see where those values show up. So all of those values are in columns here. Okay, that's what relates to the do you consider yourself a procrastinator. So no's, the people that said no, they don't consider themselves a procrastinator. Of those no's, 9 of them said no. So there's my total from my previous table. 52 said sometimes, there's that total from the table. And 26 said yes, there's that total from my previous table. If I switch over to grants and scholarships for no here, 52 people said no, they don't have a grant or scholarship. And yes, 35 people said yes, they have a grant or scholarship. If I'm comparing these two variables and I'm looking at all the different combinations, different ways people could have answered both of them, that's what's in the middle here. So somebody could have said, no, I don't consider myself a procrastinator, and no, I don't have a grant or scholarship. There were 6 people that said no to both of those questions. There were 30 people that said they're sometimes a procrastinator and that they don't have a grant or scholarship. So I'm lining up the column and the row answer for that 30. Okay. Just jumping around, 22 people said they were sometimes a procrastinator, but that they did have a grant or scholarship. Okay. So these are all the possible ways people could have answered and the number of people that answered the 2 questions in that particular combination. I can put this into a relative frequency distribution. So those 6 people here that said no and no, out of the 87 total, they make up 6.9%. So those 6 people divided by the 87 total give me 6.9%. So now I have a percent of all the students that answered no to both questions. 34.5% said sometimes they're a procrastinator, but no, they do not have a grant or scholarship. That's taking these 30 people and dividing by 87. And I can see my percents for the totals on the ends here. So 10.3%, 59.8%, 29.9% from our first relative frequency table for just the variable, do you consider yourself a procrastinator? That shows up down here. And the percents of the total of grant and scholarships show up over here. Okay, so they add up, everything adds up to 100% here. This is one way of dealing with relative frequencies in a table. It's just showing the same numbers as our previous frequency table, but just now in comparison to the total of everyone. This is probably the most common way you see these tables laid out. They're just meant to kind of describe the data. There's a few different graphs you can use to show data in bivariate categorical data. Again, just like univariate, it's not a lot of options, but that is what we have for this.